So we were discussing in the last class if f and g are periodic functions, then f plus minus z, f into z, f by z, not necessarily to be periodic, right? And we have taken one example also. We'll take one more example. Suppose we are talking about a function sine pi x plus, suppose, fractional part of root 2 of x. So here both the functions are periodic. Now we have to check whether this function fx itself is periodic or not. So let us try it. The period of sine pi x, let us call it to be t1, will be 2 pi by pi, that is 2. And if I call the period of root 2x, fractional part of root 2x, as t2, it will be 1 by root 2, right? Which can be written as root 2 by 2. So the period of fx, if I call it t, will be equal to LCM of 2 comma root 2 divided by HCF of 1 and 2. HCF of 1 and 2 is 1. Now LCM of 2 and root 2, it is not defined actually. Okay, here we have to learn one thing. The LCM of one rational number and an irrational number does not exist. LCM of two numbers which are rational only can be found out, and LCM of two like irrational surds can be found out. Okay, one rational number, one irrational number, we cannot find out the LCM. So does not exist, and that is the reason why the function f is not periodic. We'll call it aperiodic with no fundamental period. No fundamental period does not exist. Okay, so this is an example where both the functions are periodic, but the sum of them are not going to be periodic. Today in this class we'll emphasize on more of problem solving. We'll discuss some questions which are very useful and that has been asked in the previous years IIT-JEE mains and advanced. Okay, in the first question, if f of x minus 3 equal to f of x plus 3 for a function, then find the period of f. Okay, so what we'll do here in this kind of questions, this is a kind of question, this is a series of questions of this kind will be coming up. Okay, so what we'll do, we'll replace x by the nearest value of whatever value available, either x minus 3 or x plus 3. We'll go for x plus 3. Okay, so what we'll get in the left hand side, if I'll replace x by x plus 3, I'll be getting fx, and here I'm going to get f of x plus 6. So this is the definition of periodic function, right? If f of x equal to f of x plus 6, so we'll call that period of, it is periodic function, f is a periodic function with period 6. Okay. The second question, if f of x plus 4 is equal to f of x plus 2 plus f of x plus 6, we have to find out the period of f. So the solution goes like this. What we'll do, we'll replace x, and we'll generally we replace x by the nearest value available. Okay, x plus 2, we are going to replace x by x plus 2, and we'll check what will happen. In the left hand side we'll be getting f of x plus 2 plus f of x plus 6 is equal to f of x plus 4 plus f of x plus 8. Again, this is a new equation we have got by replacing x by x plus 2. Now this side, left hand side of this equation is same as that of this. Again, so if I compare these two equations, so what I'm going to get, therefore f of x plus f of x plus 4 will be equal to this f of x plus 4 plus f of x plus 8, right? So ultimately I'll get fx will be equal to f of x plus 4, sorry, f of x plus 8, x plus 4 gets cancelled, and so we reached to the definition of the periodic function. Therefore period of f is 8. Okay, these are some simple questions. The next question, if f is an odd periodic function with period 2, then we have to find the value of f of 4. Okay, so the solution will go like this. According to the question, f is periodic with period 2, so we'll get f of x will be equal to f of x plus 2. Okay, also it is given that it is an odd function, so we'll be getting f of minus x is minus fx. Okay, if I need f of 4, I have to put the value of x equal to 2 here, so that I'll get f4 equal to f of 2, but f2 is not here. f4 will come in terms of f of 2. Okay, now the period is also 2, so f2 will be equal to what? F of 0. So if I can get f0, this question is solvable, right? So how do I get f of 0 from here? We'll try to get f of 0. Okay, so what I'll get, if I'll put x equal to 0 here, f of 0 will be equal to minus f of 0. So ultimately I'll get 2f of 0 equal to 0. So ultimately I'll get f of 0 equal to 0. So it's over now. Okay, so what we'll do, we'll put x equal to 0. So what I'll get, f of 0 equal to f of 2. Okay, now if I'll put x equal to 2, so I'll be getting f of 2 equal to f of 4. F of 2 equal to f of 0, f of 0 is 0, so ultimately f of 4 will be also equal to 0. So this is how we have to think, we have to analyze in this kind of questions. Okay, this is the next question. Consider a function f satisfying f of x plus 4 plus f of x minus 4 equal to fx for all x. If f is periodic, find the period of f. This is what we have to find out the period of f. Okay, so again this is a kind of question just like the previous ones. We have to find out a suitable substitution for x, and then we have to work on, and our aim should be to get something like this. Fx would be equal to f of x plus t. Okay, so that we can declare t to be the period, right? So first of all, let us start with this one as equation number 1. Okay, so what I'll do, I'll replace x by, generally that x substitution will be the nearest value of x, most general case. Okay, so x will replace as x plus 4. So in the left hand side of this given equation, we'll get f of x plus 8 plus fx equal to f of x plus 4. Okay, now we have to think, this is suppose the second equation, new equation. Now equation 1 and equation 2, we have to think what can I remove which is not required. Okay, so what I'll do, I'll just add 1 and 2, so that fx and fx plus 4 in the left hand side also f of x plus 4 and fx I'll get, so they will get omitted, right? They will be cancel out. So let me add 1 and 2. Okay, so 1 and 2 if I'll add, I'll be getting f of x plus 4 plus f of x minus 4 plus f of x plus 8 plus fx, and on the right hand side I'll be getting fx plus f of x plus 4, right? So this is what I was talking about. This f of x plus 4 and this fx will cancel out, and I'll be getting a new equation involving f of x minus 4 plus f of x plus 8. Again, we must not forget what we are looking for. Our aim is to get something like this. We are looking for a relation of fx and f of x plus some positive number, right? Now in order to get fx, I have seen here I must write x as x plus 4, right? So I'll be getting fx from here. So let us do that and check, okay, from this equation from here now. So what I'll be getting, f of x plus f of x plus 12 will be equal to 0. Is it what we are looking for? No, actually we need exactly f of x equal to f of plus of f of x plus t. So here if I'll send this term there, I'll be getting f of x equal to minus of f of x plus 12. Okay, most of the students, they will write the answer is 12. No, that is not the answer. We are not looking for negative of f of x plus 12. We are looking for positive of something. Okay, so that way it will be wrong. So what we'll do, again we'll proceed with that only. So what we'll do, the previous equation was this. No, now this previous equation will be this, because we are about to substitute, so we have to think from here. So if I'll do one substitution here, f of x going for x plus 12. How this idea came, just you will come to know after I write down the equation, okay? So let me write. So what I'll get, f of x plus 12 plus f of x plus 24 will be equal to 0. Okay, I hope you already have understood why I have done this f of x plus 12. And anyway, whatever values that we always substitute that value of x which is present in the equation and nearest to x. Okay, so I have to eliminate something from here. I have to get one relation between fx and f of x plus something, right? So what I'll do, I'll just subtract a b from a. So what I'll get, f of x plus 12 and f of x plus 12 gets eliminated. Minus of f of x plus 24 equal to 0 means is equal to f of x plus 24. And this is what exactly we are looking for. So t equal to 24, that is the period of f is 24. That's the answer of this question. Okay, the next question is this. If f from R to R, that is real number to real number, is a function satisfying this condition, f of 2x plus 3 plus f of 2x plus 7 equal to 2 for all x belonging to R, then we have to find out the fundamental period of f. Okay, so we'll start this question like this. It's an easy question. So we'll take 2x plus 3 as y. So what I'll be getting, if I'll replace 2x plus 3 as y, we'll be getting this function will be reduced to f of y plus f of y plus 4 will be equal to 2. So we are writing y equal to 2x plus 3. Okay, what we'll do now, we'll write y to y plus 4. That is what we most generally we do. So f of y plus 4 plus f of y plus 8 will be equal to 2. Both this equation are equal to 2, so they have to be equal. So equating this to what we'll be getting, f of y plus f of y plus 4 will be equal to f of y plus 4 plus f of y plus 8. So we'll be getting f of y equal to f of y plus 8, and that is what exactly we were looking for, right? So fundamental period of f is 8. Coming up with the next question. The question is, let fxy be a periodic function satisfying the condition f of xy, f of 2x plus 2y, 2y minus 2x for all xy belongs to R, and zx be a function defined as zx equal to f of 2x to the power x, 0. Then we have to find the period of z. Okay, it's a very, very important question. Okay, so we'll solve it. Actually, we have to find out the period of zx, and zx is defined in terms of f. Okay, so whatever changes we have to make the changes here. Okay, because f is given to be periodic, and we have to find out the period of z, right? So we'll start with this f of xy is f of 2x plus 2y comma 2y minus 2x. Okay, so we'll replace x by 2x plus 2y and y by 2y minus 2x. Okay, and we'll check what we'll get. F of 2x plus 2y comma 2y minus 2x. In the right hand side we'll be getting 2 into x. X is replaced by this, so 2 into x, that is we are going to get 4x plus 2 into x, so 4x plus 4y plus 2y, that is 4y minus 4x, comma. The second one, what we are going to get? 2y minus 2x. So 2y, that is 4y minus 4x minus 2x, that is minus 4x minus 4y. Okay, so what we'll be getting from here, f of 4x cancel, 8y comma minus 8x. Right? Now this one, 2x plus 2y we have replaced as x. So this one is nothing but f of x comma y. So f of x comma y we have got is this. Okay, so we have to reach till here because zx is defined like this. Okay, so again we'll replace x by 8y and y by minus 8x. Okay, so this one will, left hand side will become x 8y comma minus 8x, and on the right hand side we'll be getting 8y, that is minus 64, y is 8x minus 64x comma and minus 8x, so minus 8x it will become minus of 64y, right? Still we are not there. Okay, so let us do one more substitution. X to minus 64 of x and y to minus 64 of y. This one is again x and y. Okay, so f of x y again, f of x comma y will be equal to this, so minus 64x comma minus 64y will be equal to, here we'll be getting minus 64, this one is 2 to the power 6 into 2 to the power 6 to the power 12 x comma 2 to the power 12 y, right? Again minus 64x we have replaced as x, so this can be written as f of x comma y, f of 2 to the power 12x comma 2 to the power 12y. Now in the next step what we are going to do, we'll put y equal to 0 and x equal to 2 to the power x, because I have to go there, right? So let us do it. F of 2 to the power x comma 0. On the right hand side we'll be getting f of, we are putting x as 2 to the power x, so 2 to the power 12 plus x comma 0. Okay, now f of 2 to the power 12 plus x, f of 2, is it not, will be z, and this one is zx actually, and this one will become z of x plus 12, right? F of 2 to the power 12 plus x, z of x plus 12, what will become? F of 2 to the power x plus 12 comma 0. So this one is nothing but zx plus 12, and this one nothing but zx. So we've got zx equal to finally z of x plus 12. Therefore, the time period of z, that is period of z, is 12. So option C is the correct answer.